Hello everyone. This is the Espressif web IDE with the ESP-IDF extension for Visual Studio Code for the DevCom 22 for Espressif. My name is Brian Alberto Ignacio Reyes. I work with the IDE team, basically for the VS Code extension and web IDE and other IDE features. Um, Today we will show you how this web IDE tool is implemented and how it uses the IDF extension for VS Code and how we can manage to do some code on the web. I'm gonna make a brief introduction to the layout of VS Code and Eclipse VIA, which is the base of our web IDE. We're gonna cover the basic layout and some files that you might need in order to work with this IDE. And we're gonna take a quick look at the features that we provide in the extension and what is possible to do with the extension. First, the basic layout is as follows. You have the activity bar here, and this activity bar shows a few icons. Here you can see the files, the explorers for the current project that is open. You can also search specific keywords on your project. You can also have source control management here, such as GitHub, Bitbucket, etc. This is the tab for debugging, where you can see the debugging actions in your IDE. This is for managing extensions in the VS Code scenario, so you can install extensions. But in the Web IDE, the extensions are integrated in the Web IDE, so it's not customizable. We could add any extensions if they are open source in the OpenVSX, but they have to be integrated because it's defined in a Docker file, so the container doesn't install extensions on the fly. There's also this part here where you can see the different editors that are open. You can group them as you see here. You can tab side by side, just one, etc. This part here is the panel where you can see different parts of the outputs of the extension. For example, here in problems, you can see some issues related to the source code. Let's say if you have an error in your source code and you try to build it, the problems will be shown here. The output channel is used to basically output some information. For example, our extension has an output channel called ESP-IDF. We will see this later, where we print the output from the different parts of the extension. As for example, some features like the debug adapter or the SDK configuration editor, etc. The debug console is as such. When you start a debug session, you will see the output from the debugger here, and then you can also interact with the debugger here as well. The terminal is basically your system terminal. If you're on Windows, the PowerShell. If you're on Linux or Mac OS, Bash or whatever shell terminal you're using. The status bar shows the different actions, icons that you can do. In our extension, we provide a few actions as here as well for your ease, so you can try a few things. Yeah, this is basically what I mentioned here. It just describes you in the presentation, the editor, the sidebar, the status bar, the activity bar, and the panels. We can share this presentation with the hyperlinks so you can go through more information about these features, these parts. The next part is the concept of workspace in VS Code. So Visual Studio Code has this concept of a workspace folder, which is basically a folder in your computer with your project, for example. And there is the concept of workspace, which is a collection of workspace folders, which are different projects. So you can define as different sets of projects. For example, if you have a project that is a server and a client, You can define each project client and server in a separate workspace folder, and then you can define a workspace that allows you to do several actions in conjunction together. So you can build for one project and the other, or you can debug them separately or together. We will see this. How do you define a workspace? You use this file called name that your name that code workspace file. In this file, you define each of these workspace folders. For example, here you can see how it looks in the Explorer window. If you have a single project open, it will look like this, just a project and the subfolders. But if you have a workspace, it will have this tag workspace here and all your sub workspace folders defined here. As you can see, it's a very basic JSON file that you just can define each path. This path can be local or can be in a remote location. Since VS Code now supports the code spaces, or you can have something in another server in a remote location, etc. So this can be defined here as well. There are three main configuration files for VS Code. As you can see here, in a single project, you will have that VS Code directory. In this VS Code directory within your project or your workspace folder contains a set of files that allows you to work with your project with VS Code for more ease. These are these three files. The launch.json defines the debugging configuration for your workspace folder. So this is just things that you want to customize in the debugging session, the elf file you will want to use, the timeout, etc. The tasks JSON, these are for defining automation tasks. For example, if you want to do some parsing of some binaries, or you want to execute something before that the debugging session starts, this can be defined here. The settings.json is basically how you configure the Visual Studio Code and our extension behavior. So for example, you can define the baud rate for the monitor. You can define the serial port that you're going to use for a specific project or workspace folder, etc. The tasks JSON is always defined on each workspace folder, and there is a set of predefined variables you can use in the task JSON and the launch JSON. There is hyperlinks here, but basically this is VS Code documentation. You can see more in their Microsoft VS Code website. This is an example of a task JSON. For example, this is just running a shell script. Here you can see the different parts. There is the command, there is the Windows, there is also OS X or Linux equivalent for if you need to modify this. The presentation is for the problem step parsing, so you can define how it's gonna execute in the terminal and how to capture errors, etc., etc. The launch JSON has this kind of definition. Basically, there is a type which defines the kind of debugger you're gonna use. VS Code use the concept of a debug adapter and debug adapter protocol, which is a middleman between VS Code and the actual debugger you're gonna use. For example, Node, VS Code uses a Node debug adapter that will talk with Node, and it doesn't talk directly to Node, but it has a small set of code that will talk to the Node itself. The program is the entry part, etc. The arguments for your debugger, this kind of typical data for a debugging session. The settings.json is where you define the settings of your extension, and they can be defined in three different places. They can be defined within your workspace folder, as we saw before. They can also be defined in the workspace. This is within the code workspace file, or it can be defined as well in the global user settings in the VS Code. You will see that in VS Code, the command palette, you can have workspace settings, workspace folder settings, or the global or user settings. This is an example of a code workspace with settings. So this will define, these settings apply for both the workspace folder VS Code and VS Code docs. So let's say if this is client or this is server, it will be defined in, these settings will be defined for both projects. But if this project has a value of this setting, the value in this project will override this value here. So the value always comes from global, workspace, and workspace folder. You can see here, you can also define launch configuration in the code workspace for us here. And this is the example I mentioned before. So if you want to have a debugging session that runs both client and server, you can define such scenarios here with the compounds configuration here. With the compound, we'll just use a configuration here, launch server, and launch client will be, which will be a single configuration for each of these workspace folder. Now we're gonna take a look at the few features that our extension provides. The extension basically provides some automation task and some UI for some wizards and some tools that allow you to work with ESP-IDF projects with ease. For example, there's a simple command for build, flash, and monitor the ESP-IDF projects. There's also the size analysis of your project. There is a GUI SDK configuration editor. There is the new project wizard and the show example projects that allows you to create projects with ease from the ESP-IDF examples. There is also a partition table editor and a MBS partition UI editors. And also there's a few like flash binary to partition commands. There's these are UIs that allow you to define a partition table, comma separated values file with this in the UI and some validation. You can try this. We also have the heap tracing and the system view UI tracing. This allows you to, if your project is configured to do a application level tracing and heap level tracing and system level tracing, you can, there's features in the extension that allows you to run these traces from the extension. It will generate the trace files, and from the trace files you can have some visualization, for example some plots and some usage of your system, and then you have some advanced system. For example, this one you can use something like a sysviewer, some advanced system usage visualization. If you configure the extension properly, the extension also allows you to run the OpenOCD server, because all the settings of ESP-IDF tools are configured with the configure ESP-IDF extension, which will help you to configure and download all the ESP tools in ESP-IDF. So if the tool is configured correctly, you can run the OpenOCD server, or you can just run the debugger, and you can just press F5 for debug, and it will execute the ESP-IDF debug adapter, which will also connect to the OpenOCD server. We also have Espressif QEMU integration for Docker containers and WSL. So basically, we will see this in a bit further when we see the example. But basically, if you are running in a system that has QEMU in the path, you are able to execute to debug using the QEMU fork we have. Currently is ESP32 target, but we are working for other targets for you can do some emulation testing. We also have some code coverage for the text editor. If you enable GCOF in your project, you are able to add some features of the text editor. If the GCOF files are generated, you can highlight your text editor and see the number of times that a line is executed. You also have some other features. You can search some keywords in the ESP-IDF documentation from the VS Code itself. You also are able to integrate with other frameworks such as ESP-IDF, ESP-MDF, ESP Matter, and you also have the Rainmaker login and node modification. So if you log into Rainmaker in the VS Code or our web IDE, you can log in and then you can see your nodes associated with your ESP Rainmaker node, and then you can modify values of each node, etc. These other frameworks, basically, you are able to download these frameworks in your desired location, and this will set some configuration settings in the extension, which will be added when you're trying to build specific ADF projects. These are also will be visible in the show examples and new project with Serve Windows, so you can create projects from these examples. Now, some of the specific features of the web IDE itself. So the web IDE itself is based on the Eclipse Thea. The Eclipse Thea is the open source project which allows you to create IDEs for web or for desktop with ease based on Electron app. And you can do that from both the website or the local scenario, but they are based on their API is very similar to the VS Code, and they support VS Code extensions as well. So you could add some these things to your custom web ID, which is what we do here. So we add our ESP-IDF extension, but we also add some desktop companion. The desktop companion allows you to, in the case of the web IDE version, you can connect to the desktop companion that is running locally in your system. So let's say you open your web browser, you're running the web IDE, but you want to flash your serial device. So what you can do is you can connect to the desktop companion. The desktop companion will be running in your local machine, and you set a specific serial port, and it will talk to the serial port, and it will flash and start a monitor, which will add it in the web IDE. And then this allows us to do the flash monitor in the ESP-IDF Docker file, which is the one that we use in the web IDE. So the web IDE, we have published web IDE Docker image already, but you can also build from the Docker file in the web IDE project that is here in this hyperlink. You see IDF web IDE. Here we have the project, it's open source, but there's the Docker file, which basically will take the ESP-IDF Docker file and extend it and adding QEMU, adding this web IDE source code, and it will provide you with a web IDE that you can run on the browser. And the desktop companion here, we also have provided a release in the IWDC. And then there's release for Windows here, which you can specify here if you want to just use an executable for Windows, or you can just run the Python script, which is available in the source code here. For example, Mac OS and a Linux device, you can just run the Python script. Okay, so it's time to switch to Visual Studio Code, but in our case, will be more directly to Thea and to see this in action. Okay, so here I have a running device in the Thea. Basically, Thea is basically what you expect in the browser, but it's the same as VS Code here. Like the UI, as you can see, is exactly the same. I wanted to show you a few features here. If you see here, I press F1 and I type ESP-IDF. I can see all the commands that are provided by this extension. So you have a few things that you can do. For example, you can launch the QEMU debug session. You can launch the show examples as this window here. You can build your project. You can start SDK config monitor, etc. We have a lot of commands that we provide. You can take a look at the VS Code extension for more information about these things. This is, for example, the ESP-IDF examples. I just run the command and I will see this window. I can see all these examples. Then I created a project using this button here. This will create a project here that will create this current project that we have open here. And then we can run, for example, using these things here, these quick action buttons, for example, the build, we can do the full clean, we can do the menu config, the SDK configuration editor. This will allow you to select the current project if you have multiple projects. If you have a workspace, you can switch between one workspace folder and another with this command. You can also select the target here. It will show you the different targets. This will allow you to select the different ports. Build, select the flash method. We support UART, JTAG, and DFU flashing methods, but these are for the VS Code extension itself, not the web version. And then here you can do the actual flashing. This is for to start the monitor. This will run build flash monitor. This will open a ESP-IDF terminal with the values loaded. And this is for executing custom tasks. For if you have defined the IDF custom task configuration setting, you can define tasks there, and when you do this, it will execute here. So let's say you open up the Blink example project here. As you can see, there is some text highlight configuration here. If I highlight this function, for example, I can see some description. These are provided by the CLang extension that is here. You can see that the CLang extension for OpenVSX for THEA is also available on VS Code extension as well. They will use the compiles command JSON from your build, and it will help you to recognize this go to definition and go to declaration functions. Then you execute the build. When you execute the build, it will show you on a terminal such as like this. And after the build is done, it will show you this task, the ESP-IDF size, which will show you the results. You can see here the result of my Blink example here. Then if I want to start a QEMU session, for example, after you finish building, it will do this one, launch QEMU debug session. What it will do, it will start the debug adapter. First, before the debug adapter is run, this task merge flash binary will be executed because QEMU is launched here. You will see this set scenario here. This QEMU will start, but it needs one binary file. So this task merge flash binary is done automatically when you launch the QEMU session. This will run this task that will combine all the flashing, all these binary files into a single binary. After all this task is executed, you can see that the debug session has started. And then you're using a QEMU here to test your current project. Then you can see the values here. You can see the different values. You don't have any locals because it's still not locals here. You can see some register values as provided here. There are some other things that you can do here for typical debug experience here. Go to declaration, etc., etc. Yeah, and then this will finish the debug session. We will finish for now. Other features you can see here, this already finished. This is the SDK config editor. For example, here, this is started by this button here, or you can just press F1 and the command SDK config editor here. This will open these windows, which allows you to go to a specific configure your device. You can also search for a specific values, etc. And that's it. Then you save the modifications, and it will update. You will need to rebuild again, but that's one of the things. This is one of the ESP-IDF Explorer things. This will provide you with some other features. Depends if you want to use. And there are other these configuration things here. For example, we have a web serial, which we are currently working on. It's an open pull request on the web ID. But basically, you can connect the device with the ESP-IDF to here. You connect, you pair the web serial for your Chrome. You pair it to this device here, to the same way that you do in UART. And then here you play, for example, flash with web serial. It will start flashing. You can see the results of flashing here. Then this flashing using web serial, don't need the desktop companion anymore. And that's it. That's pretty much it from for this presentation. So that's basically most of the features. There's many other features that we have yet to show, but due to time restrictions, we cannot show them all. You can take a look at the VS Code extension GitHub repository for many tutorials that we show the different features we have. This is things for talk in the future. What is next? We're constantly trying to improve the extension. We're trying to automate more and less complexity, less configuration. We are working on improving more of the system view tracing. We want to add more KME features and improve the emulation development. We are currently, as you saw, the web serial for Web IDE is working. It's already there, but there's a few improvements we need to do. Also, we want to improve the setup workflow and cover more setup cases. And also, we are very happy to receive any recommendation and feedback you guys feel that is needed in the extension and what we want. So anything you want in the extension that could make better or something you want to automate, we are happy to get any feedback. Yeah, basically that's it from here. Thank you for your attention. Please check the GitHub repository for the VS Code extension, especially our documentation, see how we can improve, and any feedback and suggestions you may have. This will be the part in the presentation for the Q&A, but this will happen after. Thank you so much for your attention.
Okay, it's time for one more Q&A with Brian. Thank you for your talk. Now I will welcome you, Brian, to the Q&A. How are you?
Good. How's it going? Can you hear me well?
Yeah, perfectly. Yeah. So we have some questions here. So the first one is quite interesting because if I have multiple ESP-IDF versions installed in my computer, like 4.4 or even 4.0, is there a simple way to set up a project in VS Code to use one or the other?
Yeah, so well, we have a setup wizard called, it's a command called configure ESP-IDF extension. It's a UI wizard that allows you to set up the extension in several ways. You can just use, for example, one of the options. If you follow our tutorials in the GitHub repository, you will see that there is several versions. There's Express, Advanced, and using existing setup. So if you choose Express, you will see an option that allows you to select ESP-IDF version or find ESP-IDF in your system. So you can just choose one of the IDF versions in your system, your Espressif IDF tools path, and then you can use those. You can change that with just a few clicks. You choose these two locations, and then the set wizard will configure the extension for you. And then you can change like you can just use the extension after that with the new version that you have used. As you can see in the talk, settings have different precedence. So you also should think if you want to use a specific version for a specific project, you can do so by setting settings in a specific project. For example, if you have a project, let's say you have let's say project A, and you want to use 4.4 on project A, and then you have project B, you want to use 5, then you can just define on each project, there is a VS Code folder, and there's a settings JSON that you can define there. Or you will see this if you create the IDF project from one of our examples. This will have a settings JSON, and you can define settings in each folder. So you can define a version for each project. So that's it. That's you are able to use this. There is a multi-projects configuration that allows you to set either one of those, and we are looking forward. If you have any suggestions or something to make it even more easier to do so, please just leave a feature request or issue in our GitHub repository. We are always looking forward to improve the extension.
Okay, thank you. We have another question here from Tony. Is there any plan for a better support or a template for multi-project plus shared components structure?
So Tony, this really depends on the architecture of your project, right? Because you can have multiple projects being reused. One thing, if you follow the talk, you see that you can define different projects and then you can do several tasks. For example, you can have in VS Code, you have a workspace which can contain different folders. So let's say each workspace folder represents a project. As you saw, there is a client and there is a server, for example. These are two projects, for example, and you can switch between one and fourth by selecting the current active project in VS Code. Um, you can build Flash and debug for a chosen project. But if you want to share components, I think this is a slightly more manual configuration issue, because you can define projects in your CMake list files, and then you say, okay, I can just import back components from this location and that other location. So I think it's pretty much up to you, like sharing components. If you follow the Espressif documentation, you can see that there are several ways you can, several places where you can define your specific components, and each component also like project component, or you can have a common component folder. But that is more related to the IDF or ADF or any framework you're using, the documentation you are using.
Okay, thank you. I think we have time for one last question. So, how can I get started with IDF Web IDE?
Very simple. There is a repository, a GitHub repository of the Web IDE. I think it's shared on the chat, but I will send also as well. Basically, this repository has the source code, but there's also have published the Docker image, and the Docker image is also published in Docker Hub in ESP-B Ignacio. You can just use the Docker image and toy around with it if you want. You can build it from the source code. There is instructions in the GitHub repository. And basically, you have whatever you have from your VS Code extension is already available. Not everything, but most of the stuff is already available in the Web IDE. You can refer to the VS Code extension documentation for tutorials. And the Web IDEs, the main differences are the way you will flash. You will use either Web Serial or the Desktop Companion, which are defined in the GitHub repository.
Okay, so again, thank you so much for your talk. Thank you for the answers, and thank you.
Thank you, Pedro. Thank you, everyone. Keep going with DevCon.
Thank you. Bye.